Section 2.1, Linear Equations in One Variable. This triangle represents our basic foundation from constants and variables all the way up to equations. Our constants and variables are our foundation. Constants are like our numbers, 2, -1/5, 3.5. They never change, they're constant. Variables do change. For example, some of the variables we use are x, or y, or z. From there, we build expressions. Expressions combine constants and variables. For example, 3x plus 2, or 2/3 x minus 6. You will not see equal signs with expressions. Then from there, we build equations. Equations will have an equal sign. For example, 2x minus 3 equaling 10. Equations can be true or false. So make sure you always check your answers. To solve a linear equation in one variable, here are the steps to follow. Most of the time they will lead you down the right road. First step is to remove parentheses. Second step, combine like terms that are on the same side of the equal sign. Third, get the variable on one side and numbers on the other side of the equal sign. So all that means is to isolate the variable. Step 4, divide if necessary to get the variable having a coefficient of 1. And lastly, check your answers. Always check your answers. So let's follow the steps for number 1. The directions say solve and check. First step was to remove parentheses by distributing, which we don't have any parentheses to distribute. Second was to combine like terms that are on the same side. There's no like terms that are on the same side. So the next thing is to get the variable on one side and numbers on the other. To do so, subtract 6y on the left side, so we'll subtract 6y on the right side. Since we brought the variables to the left, let's take the number to the right. So we're going to add 2 over to the other side, so 2y is going to equal a -8. And lastly, was to divide to get the coefficient having, to get the variable having a coefficient of 1. So we'll divide by 2, and so y is going to equal -4. We can plug that back in and make sure it checks. Always plug back into the original. When we plug back into the original to check this answer, we would have 8 times -4 minus 2 on the left-hand side, and that's supposed to equal 6 times -4 minus 10. So we're going to put a question mark because we're not sure if that's true. 8 times -4 is -32 minus 2, and -32 minus 2 is -34. That's what we get on the left-hand side. On the right-hand side, we get -24 minus 10. Putting those two together, we get -34 as well. So we do see that our answer of y equaling -4 does check out. So now let's do number 2. Number 2, we do have some parentheses, so we must distribute to get rid of parentheses. Make sure when you do so, you also distribute that negative. So we have 3 minus 10x, but plus 25, and that's supposed to equal -2. Since we do have some like terms that are on the same side, we'll combine them. We have a 3 plus 25. So when we put those two together, we get a plus 28, still equaling a -2. We'll then get the variable on the left and the numbers on the right, so we'll subtract over the 28, and we end up with -10x equaling -30. Lastly, we need to get the variable having a coefficient of 1, so we'll divide by -10 on both sides, so x is going to equal +3. We can certainly check this one as well, but I will let you do that on your own. Going down to number 3, first thing we want to do is get the variables on one side, numbers on the other, since we don't have any parentheses, nor do we have any like terms that are on the same side. So first thing we'll do is subtract 3. So we end up with -5/3 a equals 20. At this point, there's many different ways to get rid of that fraction. I'm going to show where you do one step at a time. The thing that we want to get rid of first is the dividing by 3. So I'm going to multiply both sides by 3 over 1. You can certainly multiply by the reciprocal, but again, I'm just showing every step. When I multiply by 3 but divide by 3, I just end up with a -5a. But 20 times 3 is 60. And then to get the variable having a coefficient of 1, I'll divide by -5. So I do end up with a equaling -12. Many ways to get rid of the fraction. I just do one step at a time. So looking at number 4, yes, we have lots of fractions, and I know everyone just loves fractions. But again, in this whole Math 116 course, we will have lots of fractions. So let's get used to working with them. Going down our list of steps, there are no parentheses to get rid of. Second step is to combine like terms that are on the same side. There's no like terms that are on the same side. So the next thing to do is to get variables on one side and numbers on the other. So to bring the negative 1/6x over, I'm going to add it. And then we'll take the negative 3/4 over to the other side by adding. So I will end up with 2/3 x plus 1/6 x equals the 21/4 plus 3/4. The right hand side has a common denominator, so I'll go ahead and put those two together. 21 plus 3 is 24 over 4, so we just end up with 6 when we divide that out. However, the left hand side does not have a common denominator. Common denominator would be 6, so I need both of my denominators to become a 6. Since this changed from a 6, that means I multiplied by 2. Whatever I do at the bottom, I have to do to the top, so I end up with a 4. Since the other denominator was still already a 6, that will stay as a 1. So 4x over 6 plus 1x over 6 turns out to be 5x over 6. So just like the previous problem, how we got rid of the denominator first, I'll multiply both sides by 6 over 1. Again, you can do the reciprocal if you'd like. At this point, 5x times 6 but divided by 6 is just going to turn out to be a 5x, and 6 times 6 is 36. Lastly, I'll need to get the variable having a coefficient of 1, so I'll divide by 5 on both sides, and I'll end up with x equaling 36 over 5. I'm going to let you try number 5, but I will give you the answer to number 5. The answer to number 5 is x equaling negative 41,900. So try that problem out on your own. The next part is to solve for an indicated variable. Really, this should be actually a little bit nicer than working with all the numbers, but for some reason this does give some students a little bit of difficulty. So let's talk about what it means to solve for an indicated variable. What that means is just get the variable by itself. So looking at number 6, the formula is I equaling p times r times t. It's all multiplication. So the opposite of multiplication is division. So to get r by itself, all I have to do is divide both sides by pt. So r is going to equal I divided by pt. There's nothing really else you can do with that problem. Now looking at number 7, we have a few extra steps. We have ax plus by equals c. We want to solve for b. I tell students always try and find the term that has a variable you want and box it in. If there's anything on the same side with that term, you need to move that over to the other side first. So the ax needs to go over to the other side, and we take that over by subtracting. A couple different ways to write this, but I'm going to write it as by equaling c minus ax. Now at this point we want to get b by itself, and the only thing that's happening to it is getting multiplied by y. So the opposite of multiplying by y is dividing by y. So we'll divide by y on both sides. So b is going to equal c minus ax over y. There's a couple different ways to write that answer, but you can certainly leave it all together. Lastly, number 8. On number 8, we're trying to solve for p. So again, box in the p. When I box in the p, I see the only thing that's on the same side with it is the 1 plus rt, which is being multiplied. And the opposite of multiplication is division. So all I would need to do is divide by 1 plus rt. So p is going to equal b divided by 1 plus rt. I hope that helps with section 2.1.